A few days after the 15th of August, 1977, a man named Jerry Eman sat down at a desk in rural Ohio with a thick stack of computer paper in front of him and a red pen in his hand. The paper came folded in a long accordion, edges perforated, columns of faint numbers printed by a machine that had been running on its own for days while no one watched. His job was to read it, line by line, column by column, hunting for anything in the sky that rose above the ordinary hiss of the universe. Most of it was ones and twos, the patient background of space. Nothing worth a second look. Then he reached a single vertical column near the edge of the page, and he stopped. 6 characters, stacked one on top of the other. 6, E, Q, U, J, 5. To almost anyone, it would have looked like a glitch, a smudge, a printer hiccup. To a man who had spent years learning to read this exact machine, it was the loudest thing he had ever seen come out of the sky. He took his red pen, drew a circle around those 6 characters, and wrote a single word in the margin beside them. Wow. That word became the name. For almost 50 years, what Jerry Eman circled that afternoon has been called the wow signal, and it is still the single most compelling candidate for a message from beyond Earth that human beings have ever recorded. It lasted 72 seconds. It came from the direction of the constellation Sagittarius, out toward the crowded heart of the galaxy. It arrived on a frequency that, as you will come to understand, no one on this planet is even permitted to broadcast on. And then it never came back. That is the part that has haunted this signal for half a century. Not that we heard it, that we heard it once, cleanly, unmistakably, and then never again. The telescope that caught it kept scanning the same strip of sky for years afterward. Larger instruments, far more sensitive than the one that found it, have returned to that exact spot in Sagittarius again and again across 5 decades. They have heard nothing. 72 seconds of something, and then a silence that is held for the rest of our lives. There is a detail in that night that has always unsettled me. No human being heard the signal arrive. The telescope was an automated thing, larger than 3 football fields laid end to end, and it simply sat there in the Ohio dark, sweeping the sky as the Earth turned, writing numbers onto paper that nobody would read for days. By the time Eman found it, the signal was already long gone. We did not catch it. We found its footprint after the fact, the way you might find a single set of tracks in fresh snow and realize something had walked past your house in the night while you slept. If the slow, strange quiet of deep space is the kind of thing you like to fall asleep to, subscribe and settle in. This is a long one, and it is meant to be. Here is the thing I want to hand you before we begin, because everything that follows turns on it. The frequency that signal arrived on was not an accident. 18 years earlier, 2 physicists had worked out on paper the one exact frequency in the entire radio spectrum that an alien civilization would most likely choose to call us on. They published it. They told the world precisely where to point its ears. And in 1977, for 72 seconds, something answered on almost exactly that frequency, and then went quiet for the rest of human history. We are going to spend the next couple of hours inside that silence, where the signal came from, why that one frequency matters so much, what it would have meant if it were real, and what it would mean if it were not, and why the sharpest new science we have, the work done in the last 2 years to finally explain it, has not closed the case at all. It has pried it back open. To understand why 72 seconds in the summer of 1977 still matters, you have to understand the frequency, not the telescope, not the man with the red pen, the frequency, because the frequency is the entire reason anyone took that signal seriously, and it is the reason serious people still cannot fully let it go. Start with the simplest, most common thing in existence: hydrogen. One proton, one electron, the first element to form after the universe cooled, and still by far the most abundant. Roughly 9 out of every 10 atoms in the cosmos are hydrogen. It fills the space between the stars in vast, cold, invisible clouds. It is the raw material every star is built from. If you could somehow tally every atom in the observable universe and sort them into piles, the hydrogen pile would dwarf everything else combined, and it would not be close. Now here is the strange and beautiful part. A hydrogen atom, drifting alone in the dark, occasionally does something tiny. Its single electron is spinning, and so is its proton. And now and then, the electron flips the direction of its spin relative to the proton beneath it. When it does, the atom sheds a single faint packet of energy, a whisper of a radio wave. And every hydrogen atom that does this, anywhere in the universe, sheds that whisper at exactly the same pitch, a frequency of 1420.4 million cycles per second, 1420 megahertz, a wavelength of 21 centimeters, about the span of a grown man's hand. This is the 21 centimeter line, the hydrogen line. And here is a thing I love about this frequency. We did not stumble on it by accident. We predicted it on paper before we ever heard it. In 1944, in the Netherlands under Nazi occupation, a Dutch astronomer named Jan Oort set a young student named Hendrik van der Hulst a question. Were there any sharp notes, any specific frequencies hidden in the radio static of the sky that a telescope might one day pick out? Van der Hulst worked through the physics of the hydrogen atom, the spin flip, the tiny energy it releases, and concluded that neutral hydrogen across the galaxy ought to glow at almost exactly 1420 megahertz. He was not even sure it would be strong enough to detect. But he had found the note on paper by pure reasoning in the middle of a world war, years before anyone built an instrument that could hear it. It took 7 more years. On the 25th of March, 1951, 2 physicists at Harvard, Harold Ewan and Edward Purcell, finally caught the hum. Using a strange horn-shaped antenna they had bolted to a window ledge outside their laboratory, cobbled together on a shoestring. Within weeks, teams in the Netherlands and in Australia confirmed it. The note Van der Hulst had imagined in occupied Europe was real, and the whole sky was singing it. So consider the timeline. The universe's one universal frequency was predicted in 1944, confirmed in 1951, and proposed as the channel for contacting alien life in 1959. In the space of 15 years, we went from suspecting the note existed to deciding it was the doorway through which the galaxy might speak. The hydrogen line had been there for 13 billion years, humming patiently, waiting for someone to grow ears. Shrink that span down to a single year, and everything we call human history, every word ever spoken, would fit inside the last few seconds before midnight. For any single atom, the flip is almost unimaginably rare. Left to itself, a given hydrogen atom will wait, on average, around 11 million years before it happens once. Put that in human terms and it is absurd. If one flip were one heartbeat, a single atom's pulse would be slower than the entire span of time since our earliest human ancestors stood upright. And yet, the sky glows softly at this exact frequency, all the time, in every direction. Because there is so much hydrogen out there, so many uncountable trillions upon trillions of atoms, that even an 11 million year event is happening constantly, somewhere, in numbers large enough to hum. The galaxy sings a single quiet note to itself, endlessly, and the note is 1420 megahertz. That changes everything about how you would search for a message from another world. Imagine you are trying to call out across an ocean to someone you have never met, who speaks no language you know, and you must choose a single channel to shout on, knowing they must somehow guess the same channel in order to hear you. You cannot send them a note in advance. You have to pick a frequency that any thinking creature, anywhere, with the tools to listen at all, would independently arrive at as the obvious one. Not an arbitrary number, a number written into the structure of the universe itself, a number that every astronomer on every world would already know, because the moment they built their first radio telescope and pointed it at the sky, they would hear that same soft hum and recognize it for what it is. The hydrogen line is that number. It is the one frequency that does not belong to any culture, any planet, any species. It belongs to the cosmos. And so the argument goes that if anyone out there ever decides to call, deliberately, on purpose, hoping to be heard, this is the channel they would choose. Tune your receiver here, and you are listening on the one door in the entire radio spectrum that everyone in the galaxy already knows how to find. Two physicists were the first to put that argument into print, and the story of how they did it is worth sitting with. In 1959, Giuseppe Cocconi and Philip Morrison were both at Cornell University. Morrison had a heavy history behind him. He had worked on the Manhattan Project, had helped assemble the core of the first atomic bombs, and had come out the other side a thoughtful, restless man with a gift for explaining hard ideas plainly. Cocconi was a physicist who, on a sabbatical at the great European laboratory CERN, had begun to wonder whether the powerful particle accelerators of the day might be used to beam signals between the stars. He even considered whether the answer was gamma rays, the most energetic light there is. The two of them fell into a conversation about it, and the conversation turned into something more careful. They worked through the problem like physicists. If you wanted to signal across interstellar distances using the technology a young civilization would plausibly have, radio was the answer. Light is fast and cheap to make. It crosses the void at the only speed the universe allows, and it slips through the gas and dust of the galaxy without being swallowed. The only question left was which radio frequency. And when they looked for the most natural, most universal choice, they landed on the same place the universe itself hums: the hydrogen line. Any civilization advanced enough to do radio astronomy at all, they reasoned, would already be studying the sky at 1420 megahertz, because that is where the galaxy reveals its hydrogen. So that is where you would broadcast, and that is where you would listen. They wrote it up as a short paper, barely 2 pages, and the journal Nature published it on the 19th of September, 1959. It is one of the most quietly important documents in the history of the search for life beyond Earth. They knew exactly how strange the idea would sound. So they ended the paper not with a bold claim, but with a sentence built like a dare, a line that has been quoted at the start of this search ever since. The probability of success, they wrote, is difficult to estimate. But if we never search, the chance of success is 0. What gives me genuine pause about that paper is what happened next, a few hundred miles away, with a young astronomer who had never read it. His name was Frank Drake. He was not yet 30 years old, working at a brand new radio observatory tucked into a quiet valley at Greenbank, West Virginia. And at the very same time Cocconi and Morrison were reasoning their way toward the hydrogen line on the page, Drake had arrived at precisely the same conclusion on his own, from the other direction. He had begun preparing his own search in 1959, months before their paper appeared. He had not seen it. He did not need to. He had run the logic himself and reached the same door. The two efforts were entirely independent, and they pointed at the same frequency. The telescope he had to work with was a modest one, by the standards of what would come later. An 85-foot dish named for an engineer called Howard Tattle. Drake equipped it with a single-channel receiver, tuned it close to 1420 megahertz, and aimed it at two nearby stars that resembled our Sun, Tau Ceti and Epsilon Eridani, each about 10 to 12 light-years away, close enough that a signal from either would be a near neighbor by cosmic standards. He gave the effort a name out of a children's book, Project Ozma, after Princess Ozma, the ruler of L. Frank Baum's imaginary land of Oz, a place Baum had described as very far away, difficult to reach, and populated by strange and exotic beings. It was, by any fair reckoning, the first true scientific search for an alien signal in human history. From April to July of 1960, for about 6 hours a day, the small Ozma team sat with a chart recorder and a loudspeaker and listened. A pen scratched a line across rolling paper. The loudspeaker hissed with the static of the cosmos. For roughly 150 hours of watching, nothing happened. And then, almost immediately, something did. On the 8th of April, very early in the search, Drake swung the dish over to Epsilon Eridani, and the recorder's pen suddenly swung wildly across the page. A strong, pulsed signal, regular and artificial looking, came pouring through the loudspeaker. It was, very nearly, exactly the thing they had hoped to hear. For a few electric moments, the first SETI experiment in history appeared to have succeeded on almost its first try. And then the doubt set in, the way it always must. The team checked. They brought in a second antenna, and over the following days it became clear that the signal was not coming from the stars at all. It was a high-flying aircraft, most likely a piece of secret military equipment, sweeping the sky with its own radio. It took them around 10 days to be sure. The first promising signal in the history of the search for alien life turned out to be one of our own machines passing overhead. Keep that in mind, because it is the pattern the entire field would live inside from then on. The thrill of the catch, followed by the slow, deflating work of explaining it away. Drake heard nothing else of note. Ozma ended in quiet. But the point was never the result. The point was that two different minds, with no contact between them, had independently looked at the entire span of the radio spectrum and circled the same frequency. When separate people, reasoning separately, keep arriving at the same answer, it is usually because the answer is sitting in the structure of the thing itself. The hydrogen line was not one clever guess. It was the obvious channel, and more than one person could see it. The idea only grew sturdier from there. In the early 1970s, an engineer named Bernard Oliver took it a step further. Oliver, known to everyone as Barney, was a brilliant and slightly imperious figure, the head of research at Hewlett-Packard, and he became one of the architects of the modern search for extraterrestrial intelligence, working with the scientist John Billingham on a sweeping study called Project Cyclops. Oliver pointed out that hydrogen has a companion in the sky, Out in space, alongside the clouds of pure hydrogen, there are clouds rich in a fragment called the hydroxyl radical, a single oxygen atom bound to a single hydrogen atom, which glows at its own set of frequencies a little higher up the dial, near 1600 and 1700 megahertz. And Oliver noticed something almost poetic. Hydrogen is H, hydroxyl is OH. Put them together, H plus OH, and you have H2O, water. The band of radio frequencies between the hydrogen line and the hydroxyl line is, in a chemical sense, bracketed by the two pieces of the molecule that life on Earth cannot exist without. So Oliver gave that stretch of the spectrum a name that has stuck for 50 years. He called it the water hole. It is a pun, and a deliberate one. On Earth, a watering hole is the place creatures of every kind gather, warily, to drink. Predators and prey set their differences aside at the water's edge because they all need the same thing. Oliver's idea was that the cosmic water hole might work the same way. A natural meeting place on the radio dial, marked out by the chemistry of water itself, where the different species of the galaxy might gather to listen for one another. Quiet, universal, obvious to anyone. The one stretch of the spectrum where, if you were going to wait for a voice, you would wait. There is a deeper reason the water hole is the right place to wait, and it goes beyond the poetry of water. It happens to be one of the quietest neighborhoods in the entire radio spectrum. Look across all the frequencies, and most of them are noisy for one reason or another. Down at the low end, the whole galaxy roars with a broad radio hiss from electrons spiraling in magnetic fields, drowning out anything faint. Up at the high end, the warm gases of a planet's own atmosphere glow and crackle, and the very physics of radio reception adds its own unavoidable static. But in between, in a band that runs roughly from 1 to 10 billion cycles per second, there is a valley. A stretch where the galaxy goes quiet and the atmosphere goes quiet, and the noise drops to its lowest point anywhere. And the water hole, with the hydrogen line at its floor, sits right down in the bottom of that valley. So the choice was never only sentimental. If you were a thoughtful engineer on any world, looking for the cheapest, clearest channel to shout across the galaxy, you would be led to almost exactly this band by the cold mathematics of noise alone. Nature carved a quiet window into the spectrum and marked its lower edge with the most common element there is. It is hard to imagine a more obvious place to listen. By the middle of the 1970s, this was no longer a fringe notion. It was the considered consensus of the people who thought hardest about the question. If a signal ever came, it would most likely come from the water hole, and most likely from its lower edge, the hydrogen line, 1420 megahertz. That belief shaped where telescopes pointed and what receivers were tuned to for decades. It is the reason the Big Ear telescope in Ohio was sweeping that part of the spectrum at all on the night that mattered. And there is one more feature of that frequency that makes the whole story stranger. A detail that turns the wow signal from merely interesting into something far harder to explain away. The narrow band of frequencies right around the hydrogen line is protected. By international agreement going back decades, that slice of the spectrum is set aside for radio astronomy and radio astronomy alone. No one on Earth is allowed to broadcast there. Not radio stations, not television, not military transmitters, not satellites. The reason is practical. The hydrogen line is how we map the gas and structure of the entire galaxy, and a single, loud human transmitter sitting on that frequency would blind us, the way a streetlight blinds you to the stars. So the world's governments agreed, in effect, to keep that one channel quiet, to leave the cosmic door closed on our end so we could hear anyone knocking from the other side. Hold those two facts together, because the rest of this story lives in the space between them. There is one frequency in all of radio that thoughtful people decided, independently and repeatedly, was the channel any civilization would use to call across the stars. And it is a frequency that no one on Earth is permitted to transmit on, kept deliberately silent by treaty. So when a powerful, narrow, unmistakable signal arrived on almost exactly that frequency in the summer of 1977, pouring out of an empty patch of sky toward the center of the galaxy, it landed in the one place where, by every rule we had written, it should not have been able to come from us, which left only two doors open. Either something we did not understand was happening out in the universe, or someone, finally, was knocking. To understand which of those two doors we were standing in front of, you have to stand inside the building where it happened. And the building, like almost everything about this story, was stranger and humbler than you would expect. The telescope was called the Big Ear. It sat in a field outside the small town of Delaware, Ohio, on land borrowed from a neighboring university, and it looked almost nothing like the giant white dishes most people picture when they think of a radio telescope. It was designed by an Ohio State astronomer named John Krause, a man who had spent his life inventing clever ways to listen to the sky, and the design that carries his name was his answer to a simple problem. Big dishes are expensive, so instead of one costly bowl, Krause built something flatter and cheaper and enormous. Two great metal walls and a vast aluminum-covered plane laid out between them, the whole assembly larger than 3 American football fields placed side by side. If you had walked the length of it, you would have walked the better part of a quarter mile. It had been built across the late 1950s, switched on in 1963, and by the time our story reaches it, it had been listening to the sky for well over a decade. For its first years, the Big Ear did sober, useful work. It carried out the Ohio Sky Survey, a patient mapping of the radio sky that catalogued nearly 20,000 cosmic radio sources, around half of which no one had ever recorded before. It was respectable science. And then, in the early 1970s, the telescope was turned to a purpose that most serious astronomers of the day considered somewhere between eccentric and embarrassing. It began to listen, full-time, for signals from other civilizations. Under a scientist named Robert Dixon, with John Krause presiding over the observatory, the Big Ear became home to the longest-running search for extraterrestrial intelligence in history, a search that would run on a shoestring for more than 2 decades. The team was so devoted and so underfunded that they ran their own little magazine about the search, called Cosmic Search, which published a handful of issues before the money ran out and it quietly folded. This was not a glamorous, well-resourced enterprise. It was a few committed people and a great flat ear in an Ohio field, keeping watch on the cosmos because someone had decided it was worth doing. The way that ear listened is the first thing you need to hold on to because it matters enormously later. The Big Ear could not turn. Most telescopes swivel and track, following a star across the night, the way your eyes follow a bird across a window. The Big Ear could do no such thing. One of its great flat walls could be tilted, slowly, to aim at a particular strip of sky, and then it simply held still. Dead still. And the Earth did the rest. As our planet turned beneath the stars, the sky itself drifted slowly across the telescope's fixed gaze, the way the view drifts past the window of a train. You are sitting still inside. A radio source would rise into the telescope's narrow field, pass through it over a few minutes and slide out the other side. After a few days of watching one strip, the operators would nudge the Great Wall a fraction and let the Earth carry a new strip past. This is called a drift scan, and the Big Ear was one of the finest drift scan instruments ever built. Here is why that detail is going to haunt the rest of this story. Because the telescope held still and let the sky drift past, anything truly out in space would not appear as a steady tone. It would swell and fade. As the source drifted into the edge of the beam, the signal would grow. As it reached the center, the signal would peak. As it slid out the far edge, the signal would die away. A slow rise and a slow fall, smooth and symmetric, stretched over the few minutes it took the Earth to carry that patch of sky across the telescope's view. That shape, that gentle swell and fade, is the unmistakable fingerprint of something truly in the heavens, rather than a passing car radio or a glitch in the electronics. Remember the shape. It is going to matter more than almost anything else. And remember one more thing about the Big Ear. It had 2 ears. The telescope used not one, but 2 feed horns. 2 separate receivers set slightly apart, each one staring at a slightly different patch of sky. As the heavens drifted past, a source would cross the first horn's view, and then, about 3 minutes later, cross the second horn's view, like a runner breaking first one tripwire and then a second one a short distance down the track. So a real steady source in the sky left a very particular calling card. It appeared twice, once in each horn, roughly 3 minutes apart. 2 matching swells and fades, separated by that small, predictable gap. Hold that fact in your hand. We will need it before the night is over. The work itself was unglamorous in the extreme. The telescope swept the sky on its own. An IBM computer recorded the strength of the radio waves in 50 narrow channels at once, and a printer translated all of it into long columns of numbers on folded paper. There was no screen flashing an alert, no alarm, just paper accumulating in a quiet room, waiting for a human being to come and read it. The human being was Jerry Eman. By then, he was a volunteer, donating his time to the project, and part of his job was to take home the stacks of printout and go through them by eye, line by line, looking for anything that broke the pattern. It was tedious work of the kind that builds a particular kind of patience. You learn the ordinary so deeply that the extraordinary jumps off the page at you. The ordinary, on those pages, was a quiet scatter of 1s and 2s and the occasional 3. The soft, random noise of the universe and the receiver. That was the background. That was every page, most days, for years. The signal had actually arrived a few days before he found it, late on the night of the 15th of August, at around 16 minutes past 10 in the evening, while no one was in the room. The telescope caught it, the computer logged it, the printer wrote it down, and then everyone went on with their lives for several days while the paper sat in its stack. When Eamon finally sat down with that batch and worked his way to the right page, he found in a single channel, in a single vertical column, 6 characters that did not belong to any quiet night he had ever seen. 6, E, Q, U, J, 5. To read what those characters meant, you have to understand the code the project used, and once you understand it, the hair on your arms may stand up a little. The computer measured the strength of each signal against the background noise and gave it a single character to save space on the page. A blank space meant the signal was barely above nothing. The digits 1 through 9 meant a signal 1 through 9 times stronger than the background. And when a signal climbed past 10 times the background, past what any digit could express, the code switched to letters. A was 10, B was 11, and so on up the alphabet, each letter another full step louder than the last. So read the sequence again, slowly, as a story of rising and falling loudness. 6, a signal 6 times the background, already unusual. Then E, the 5th letter, meaning around 14 times the background. Then Q, deep into the alphabet, around 26 times. Then U, further still, the loudest character on the entire page, a signal roughly 30 times stronger than the quiet hiss of the universe behind it. Then J, falling back to around 19. Then 5, dropping toward the ordinary again. Look at the shape of that. 6, 14, 26, 30, 19, 5. It rises, it peaks, it falls. A smooth swell and a smooth fade, each character a single 12-second slice of time, the whole event stretched across about 72 seconds. And that shape, that exact rise and fall, is precisely the calling card the drift scan was built to catch. It is what a real source in the sky looks like as the turning Earth carries it into the beam, across the center, and out the far side. The signal was not a steady artificial blare. It was not a momentary spike from a faulty wire. It swelled and faded with the exact rhythm of the heavens turning. Whatever made those 6 characters was sitting still in the sky and let the Earth sweep the telescope's gaze across it, the same way a star does. That is the moment the whole thing stops being a curiosity and becomes a genuine problem. Because everything about those 6 characters pointed up and out, not at the ground, not at a satellite, up into deep space toward the constellation Sagittarius and the crowded core of the galaxy beyond it. There was more, and each new detail made it harder to explain away. The signal was extraordinarily narrow. Out of the 50 channels the receiver listened to at once, the signal showed up cleanly in essentially one, a slice of the radio dial only about 10 kilohertz wide. That narrowness is itself a kind of evidence. Nature, when it makes radio noise, tends to make it broadly, smeared across a wide range of frequencies. Stars exploding or otherwise, gas clouds, the violent debris around dead suns. They roar across the spectrum. They do not whisper into a single narrow channel. A signal concentrated into one thin band is the signature of something tuned, something deliberate, the kind of thing a transmitter makes, not the kind of thing an explosion makes. And the frequency of that narrow whisper was, of course, the one that mattered. Right at the hydrogen line, right in the lower doorway of the waterhole. Eamon went back to that measurement for the rest of his life, and the precise number turned out to be its own small puzzle. The observatory's director, John Krauss, reported one value. Eamon, working it out carefully years later for a detailed report he wrote on the 20th anniversary, settled on a figure of 1420.45 megahertz, a hair above the exact rest frequency of hydrogen. That tiny offset, about 50 kilohertz, is not nothing. If you read it as motion, as a Doppler shift, it would mean the source was drifting toward us at roughly 10 kilometers a second. Whatever it was on that reading, it was not sitting still relative to Earth. It was moving, very slightly, in our direction. But the headline never changed. This loud, narrow, smoothly rising and falling signal had landed on the cosmic front door that human beings had spent 18 years insisting was the one to watch. You can understand why a careful man wrote a single astonished word in the margin and circled the column in red. He was not claiming it was aliens. Eamon was far too cautious for that, then and ever after. He was simply marking the fact that here, on this page, on this ordinary night, was the thing the entire project had been waiting years to maybe possibly see. So they did the only sane thing. They tried to find it again. Because if it was real, if it was a beacon out in Sagittarius, it should still be there. Stars do not vanish. A transmitter built to be noticed would presumably go on transmitting. So Eamon and his colleagues swung the great flat wall back to the same strip of sky and waited for the Earth to carry that patch of Sagittarius across the beam again. They looked the next night. They looked in the nights after. They looked on and off for months, and it never came back. That failure might have ended the story, except for one man who could not let it go, and whose devotion to those 72 seconds humbles me. His name was Robert Gray, and he wasn't a professional astronomer. He was a data analyst in Chicago who chased the wow signal in his own time for love for decades, becoming in the process the single most determined hunter the signal ever had. He heard about it a few years after it happened, and it lodged in him. He contacted the Ohio team. He visited the Big Ear. He sat with Eamon, with Dixon, with old John Krause himself, and asked them everything. Then he went looking. In 1980, he started small, scanning the sky from his own backyard with a 12-foot commercial dish, the kind built to catch television from satellites. He ran that little homemade observatory for the better part of 15 years. Nothing. In 1987, and again in 1989, he secured time on a far more capable instrument, the Meta radio telescope at the Oak Ridge Observatory in Massachusetts, run out of Harvard, and aimed it at the spot. Nothing. In September of 1995, and once more, in May of 1996, Gray talked his way onto the Very Large Array in New Mexico, that famous spread of 27 dishes working as one, an instrument so sensitive it can mimic a single dish 22 miles across. He became, in doing so, the first amateur ever granted use of the Very Large Array, and the first person ever to use it to hunt for an alien signal. He pointed that magnificent machine at the WOW locale, and it never came back. He traveled to the far side of the world to a radio dish at Mount Pleasant in Tasmania, and with an astronomer named Simon Ellingson, listened for any repeating pulse from that patch of Sagittarius. Nothing there either. Gray eventually wrote a book about the whole quarter-century chase, titled, with quiet honesty, The Elusive Wow. He died in 2021, having spent more of his life looking for those 72 seconds than any other human being, and having never once heard them again. And he was not alone in coming up empty. Across nearly 50 years, the search has been taken up by instrument after instrument, each hundreds of times more capable than the Big Ear. Newer arrays built specifically to hunt for alien signals sweeping that region of Sagittarius as a matter of course. And every single time, the answer has been the same. Silence. The signal that arrived loud enough to climb 30 times above the noise on the one frequency we had marked as the channel of first contact arrived exactly once and never came back, which forces a question that has no comfortable answer. And the question hides inside that detail I asked you to hold on to. The two ears. Remember that the Big Ear had two feed horns, and that a genuine fixed source in the sky should pass through both of them, about 3 minutes apart, leaving two matching swells on the paper. The WOW signal did not do that. It appeared in only one horn. One clean rise and fall, and then nothing in the second horn 3 minutes later, where its twin should have been. One set of footprints in the snow, and no second set. And that single fact splits the mystery into two unbearable possibilities, both of which should keep you awake. Either the source switched off in the roughly 3 minutes between the two ears, turning itself on for one horn and dark for the next, which is a deeply odd thing for a star or a steady beacon to do. Or it was a thing that flared once, briefly, in a single patch of sky, poured out its narrow whisper on the forbidden frequency, and then fell silent before the turning Earth could bring the second ear into line. Something that speaks once, on the one channel the whole galaxy is supposed to share, and then never speaks again. The science had to answer a simple, terrible question. What kind of thing in this universe does that? Over nearly 50 years, every serious attempt to answer that question has fallen into one of a few families. It pays to walk through them honestly, one at a time, because that walk turns out to be far more unsettling than any single tidy answer. And it begins, as good science should, with the boring explanations. The ones that would let us all sleep easily, if only they held up. The most obvious boring answer is that the signal came from us, from Earth, or from something we put in orbit. A stray military transmitter, a satellite passing overhead, a reflection bouncing off a piece of space junk, an aircraft, a glitch deep in the telescope's own electronics. This is always the first thing a careful scientist reaches for, and Jerry Ehrman reached for it harder than anyone. For the rest of his life, he refused to overclaim. He once said, in a line I have always admired, that he did not want to draw vast conclusions from what he called half-vast data. He took the mundane explanations seriously, precisely because he wanted the signal to survive them honestly, if it was going to survive at all. But the mundane explanations keep colliding with the same three facts, and they cannot get past them. First, the frequency. The signal sat almost exactly on the hydrogen line, inside the narrow band that international treaty keeps clear of all human transmission. Broadcasting there is forbidden, on purpose, worldwide. So a casual earthly transmitter sitting on that exact channel would be both illegal and bizarrely unlikely. Second, the shape. That smooth rise and fall across 72 seconds matched the turning of the Earth, the calling card of something truly out in the sky, not something local. A passing satellite or a ground transmitter would not trace that gentle celestial curve. It would lurch or hold steady or cut off wrong. Third, the narrowness. The signal was concentrated into a single thin channel, the signature of something tuned rather than something natural and broad. Stack those three facts together and the easy answers buckle. The signal behaved like a real thing in deep space, on a channel nothing on Earth is allowed to use, with a precision that nature rarely bothers with. So the boring answers do not close the case. They never have. But before we climb toward the stranger explanations, it is worth pausing on a hard lesson the whole field had already learned more than once before the wow signal ever arrived. Because the history of this search is, in large part, a history of false alarms. And the false alarms are more instructive than almost anything else. Go back 10 years before that night in Ohio, to Cambridge, England in 1967. A graduate student named Jocelyn Bell, later Jocelyn Bell Burnell, was working under the astronomer Anthony Hewish, helping run a radio telescope she had helped build by hand. Her job was to read the output, and the output was paper. More than 100 meters of chart paper rolled out every few days, and she read it by eye. The same patient, mind-numbing work that Jerry Ehrman would later do in Ohio. And in the late summer of that year, she noticed a little bit of what she called scruff, a small repeating smudge in the data that did not behave like anything known. when she and Hewish looked closer, they found something deeply uncanny. A signal pulsing with almost impossible regularity, a sharp blip every 1.33 seconds, steady as a metronome, far too precise and too fast to come from any star anyone understood. Nothing in the cosmos was supposed to keep time like that. And so, half as a joke and half in genuine unease, they gave the source a nickname, Little Green Men 1. Because the most regular signal anyone had ever seen, ticking like a clock from a fixed point in the sky, raised a possibility nobody wanted to say out loud, that they had picked up the beacon of another civilization. Belle Burnell was the one who talked everyone down, and the way she did it is a small masterpiece of scientific thinking. She reasoned that a single artificial beacon would be a staggering coincidence, but more importantly, she went looking elsewhere in the sky, and she found a second source in a completely different direction, ticking with the same eerie regularity. Two alien civilizations in two random patches of sky, both calling Earth at the same time, was absurd. Far more likely that this was a natural object nobody had met yet. And it was. The ticking turned out to come from a pulsar, a rapidly spinning neutron star, the collapsed and impossibly dense corpse of a dead sun sweeping a beam of radio energy across the Earth like a lighthouse with every rotation. It was one of the great discoveries of 20th century astronomy. It won a Nobel Prize, controversially given to Hewish and not to Belle Burnell, who had found the thing. Hold on to that, because it is going to rhyme. The first time a signal looked so artificial that serious scientists whispered the word aliens, the culprit turned out to be a spinning, dead neutron star. Remember that. We will come back to it, and when we do, the hair may stand up on your arms again. And Belle Burnell's pulsar was not the only false alarm. A few years earlier, in the mid-1960s, a Soviet astronomer named Nikolai Kardashev had grown convinced that a distant radio source might be the transmitter of a vast alien super-civilization, and announced as much to a flurry of headlines. It, too, turned out to be natural. A quasar, the blazing core of a distant galaxy, powered by a giant black hole. Over and over, the same pattern played out. A signal arrives that looks too clean, too regular, too artificial to be nature. The word aliens hovers in the air. And then, with more data, the universe reveals that it has a deeper and stranger bag of natural tricks than anyone had guessed, and the signal resolves into some new kind of dead star or distant engine of physics. The lesson the field learned, painfully and repeatedly, was humility. The universe is a far better forger than we expect. That is the backdrop against which the wow signal has to be judged. So when, decades later, the comet idea arrived, the field was primed to test it hard. The first explanation that truly shook things up arrived in 2016, and for a brief while it looked like the mystery might finally be over. An astronomer named Antonio Paris, working with a small organization called the Center for Planetary Science, proposed that the culprit was a comet, not a famous one. Two faint, obscure comets, one named Christensen and the other Gibbs, both of which happened to be drifting through that part of Sagittarius in the summer of 1977, and neither of which had even been discovered yet when the signal was caught. Paris's idea had a real elegance to it. Comets are wrapped in enormous clouds of hydrogen gas, boiled off their icy bodies as they near the sun. Hydrogen glows at 1420 megahertz. So perhaps, he argued, one of these uncatalogued comets had drifted into the beam, its hydrogen cloud shining briefly on the magic frequency, and then moved along its orbit and out of view. That would explain the single appearance. It would explain why it never came back. The comet simply wandered off, the way comets do. To test it, Paris waited for Christensen to swing back around through roughly the same region of sky years later and pointed a radio telescope at it. He reported detecting a signal near 1420 megahertz coming from the comet and published the result. And for a news cycle, the headlines declared, "The wow! Signal solved at last. A comet. Mystery over. Go home." The mystery was not over. The response from the rest of the field was swift and, in places, withering. A comet specialist at Queen's University Belfast named Alan Fitzsimmons dismissed the whole idea in a single blunt word: rubbish. And he had reasons. For one thing, no comet had ever, in the entire history of radio astronomy, been observed emitting at the hydrogen line in this way. For another, Christensen is a feeble, sluggish object that only becomes active when it draws close to the Sun. And even at its closest, it stays more than twice as far from the Sun as the Earth is. When Paris observed it, the comet was farther out still, well over 4 times the Earth's distance from the Sun, drifting through the deep cold where a comet barely exhales at all. Out there, it would have had essentially no hydrogen cloud to speak of. Nothing to shine. Seth Shostak, the senior astronomer at the SETI Institute, lined up alongside Fitzsimmons in disagreement. And then Eamon himself, with his old colleague Robert Dixon from the Ohio State Observatory, pointed out the detail that I think quietly demolishes the whole comet idea. The 2 ears again. A comet drifts across the sky slowly, over hours and days. A steady source sitting in that patch of Sagittarius, pouring out radio waves, would have been caught by both feed horns 3 minutes apart, leaving 2 matching swells. But the wow signal appeared in only one. A comet cannot explain a single pass. It should have left 2. On top of that, the careful reconstruction of where the comets actually were on the night of the 15th puts them in the wrong place, not quite where the signal came from. The comet explanation, for all its early elegance, fell apart under its own weight. So by the 2020s, after the comet hypothesis had come and gone, the situation was almost exactly what it had been in 1977. A loud, narrow, smoothly rising and falling signal on the forbidden frequency from the direction of the galactic center, caught in one ear and never seen again. Decades of progress in radio astronomy, and the single best candidate signal we had ever recorded still sat there, unexplained, daring someone to crack it. And then, in 2024, someone did something genuinely new. Not by listening harder to the sky, but by digging through the past. A team led by Abel Mendez, who runs the Planetary Habitability Laboratory at the University of Puerto Rico at Arecibo, working with Kevin Ortiz-Ceballos of the Harvard and Smithsonian Center for Astrophysics and Jorge Zuluaga of the University of Antioquia in Colombia, went back into the enormous archive of the famous Arecibo telescope. Arecibo was, for decades, the largest single-dish radio telescope on Earth, a vast bowl set into a sinkhole in the hills of Puerto Rico until its tragic collapse in 2020. Buried in its archived recordings, in observations made between 2017 and 2020, the team went looking for anything that resembled the old signal. And they found something. They found narrow signals near the hydrogen line, with the same narrowness as the wow signal appearing in their data. Not loud, far weaker than the original, perhaps 60 to 100 times fainter, but unmistakably similar in character, and most tellingly, they could tell where these faint lookalikes were coming from. They were not transmitters. They were not civilizations. They were coming from cold, dark clouds of neutral hydrogen gas, the ordinary unlit hydrogen that drifts everywhere through the galaxy. And that gave Mendez and his colleagues the thread that pulled the whole thing into a new shape. That detail matters more than it might sound, because it is what separated this from idle speculation. The team could actually pin those faint signals to specific clouds of cold hydrogen in their data, real objects with real locations, not hypothetical ones. They were watching ordinary hydrogen gas briefly brighten on its own line, in miniature, dozens of times over. The wow signal on this picture was simply the same thing turned up to a volume we have never seen before or since. One cloud lit far more fiercely than any of its faint cousins. Once you have seen the small version happen again and again in your own data, the giant version stops looking like a fantasy and starts looking like the rare extreme of something entirely real. Their proposal is the most complete natural explanation anyone has offered, and to understand it you need one more idea. The idea of a massa. You have heard of a laser where light of a single pure color is amplified into a tight, intense beam. A massa is the same trick performed with radio waves instead of visible light, and unlike lasers, masas occur naturally out in space. Clouds of certain molecules near young stars are known to flare as natural masas, pumped up by a burst of energy until far too many of their atoms are sitting in an excited, unstable state at once. That overloaded condition is delicate, and when it tips, the whole cloud dumps its stored energy together in a sharp, narrow, intense beam at a single frequency. They are real. We see them. The question Mendez asked was whether a cloud of plain cold hydrogen could be made to do the same thing at the hydrogen line, if something hit it hard enough. And here is the mechanism they propose, and I find it beautiful even as it dismantles the romance. Picture one of those cold, quiet clouds of hydrogen sitting out in the galaxy, normally far too faint to register. Now picture, somewhere behind it, a monster, a magnetar. A magnetar is a kind of dead star, and to understand what one is, you have to remember Bell Burnell's pulsar, the spinning neutron star corpse that once looked like little green men. A magnetar is that, taken to a violent extreme. The name was coined in 1992 by two physicists, Robert Duncan and Christopher Thompson, to describe a rare breed of neutron star wrapped in the most powerful magnetic field known to exist anywhere in the universe. The field around a magnetar is something like 1,000 times stronger than that of an ordinary neutron star. And ordinary neutron stars are already so extreme, they defy easy description. The numbers are almost meaningless until you find a way to feel them. So here is the comparison astronomers like to use. A magnetar's magnetic field is so intense that, if one drifted to within half the distance of the moon, it would wipe every credit card and erase every hard drive on Earth. It would distort the very atoms in your body. These objects do something terrifying. Their crust, a shell of impossibly dense matter, is held under unimaginable magnetic stress, and every so often it cracks, a starquake. And when a magnetar's crust fails, it releases a flare of radiation that beggars description. We have seen this happen. On the 27th of December, 2004, a magnetar sitting roughly 50,000 light-years away, in, of all places, the constellation Sagittarius, let go a single giant flare. In 1/5 of a second, it released more energy than our sun pours out in 250,000 years. It was the brightest blast of its kind ever recorded from beyond the solar system, and even from 50,000 light-years away, it physically disturbed the upper atmosphere of the Earth. A dead star, half a galaxy away, reached across the void and rang our ionosphere like a bell. That is what a magnetar can do. Now let one of those flares fire off behind a cold hydrogen cloud. The torrent of radiation slams into the cloud and pumps its hydrogen atoms up into that excited, overloaded state. All of them, all at once, far more than nature normally allows. The cloud becomes a loaded spring, and then it releases, all together, in a sudden, brilliant burst of stimulated emission at exactly the hydrogen line. A natural Marsa flare. For seconds to minutes, an ordinary invisible cloud of gas would blaze on the radio dial, narrow and loud and tuned to 1420 megahertz before fading back into the dark as the magnetar's flare passes. Notice how well that fits. It would be narrow because a Marsa is intensely tuned to one frequency. It would be on the hydrogen line because that is the frequency hydrogen sings at. It would be strong because all that pumped up energy releases at once. It would come from the sky with the proper celestial rise and fall because the cloud is really out there in Sagittarius, and it would never, ever repeat because it depends on a freak alignment, a rare flaring monster sitting just so behind a particular cloud, lighting it up for a single burst that will likely never recur in any timescale that matters to us. There it is, the answer to the question that has haunted this whole story. Why did it never come back? On this account, because it was never going to. It was a one-time event, a cosmic accident of geometry and timing, a dead star coughing once and illuminating a cloud of gas for a minute before the universe moved on. The very thing that made the signal feel like a deliberate hello, the fact that it spoke once and fell silent, becomes instead the fingerprint of a violent, mindless, unrepeatable natural event. And notice the rhyme finally landing. The first great false alarm, Bell Burnell's Little Green Men, was a neutron star. And the best explanation we now have for the most famous candidate signal in history is, once again, a neutron star. The universe forged a voice out of a dead one. And yet, I have to be straight with you about how this story actually stands, because the candor is the most interesting part. Mendez and his team did not find the magnetar. They did not find the specific cloud. They found faint cousins of the wow signal in old data and proposed a mechanism that could, in principle, produce the original. But no flaring monster has been located behind that patch of Sagittarius. The imprecise pointing of the old Big Ear telescope makes the exact spot hard to pin down, which means confirming the idea would take a great deal more work and may never be fully possible. Mendez himself has been refreshingly careful about this. He has said plainly that the work does not solve the mystery. In one line I keep coming back to, he said, "The study does not close the case. It reopens it, now with a much sharper map in hand." He has been clear that an intelligent origin still cannot be entirely ruled out. What the work offers is not a verdict. It is the best natural mechanism anyone has yet proposed, sitting on the table next to a possibility no one has been able to fully eliminate. So where does that leave us, really? It leaves us with the most likely explanation being a dead star and a cloud of gas, and with the door to something stranger still not quite shut. The honest answer to what the wow signal was is the answer scientists have been circling for nearly 50 years. We do not know. We have a strong new candidate. We do not have proof. And the gap between a strong candidate and proof is exactly where the wonder lives. But the magnetar idea, even unconfirmed, does something quietly enormous. If a cloud of ordinary hydrogen can be made to flare briefly and brilliantly on the exact frequency we chose as the channel of first contact, then the universe itself can forge a false hello. It can counterfeit the very signal we built our search to find. And that possibility reaches far beyond one night in Ohio. It reaches into everything we thought we understood about how to listen and what we might be hearing when we point our great ears at the silent sky and wait. The mechanism is one thing. What it means for us is something else entirely, and it is the part that lingers after the physics has been put away. Because for a few decades, the wow signal was the closest humanity ever came to an answer to the oldest question we have. Not a vague, philosophical answer, a specific one, written on a specific page, caught by a specific machine on a specific night. For 72 seconds, the universe appeared to have said something on the exact channel we had agreed to listen on. And whatever you believe about what it actually was, you should sit for a moment with how rare that is. In all the years before, and all the years since, across every telescope and every survey, and every patient sweep of the sky, nothing else has come as close. This one signal stands almost entirely alone as the single best candidate for contact in the history of our species. That is why people could not let it go. And it is why, in the years after the comet idea collapsed, the search shifted from the signal itself to its source. If something out there had spoken, the obvious next question was simple. Who? Which point of light in that crowded patch of Sagittarius had the signal come from? And in 2020, a man went looking for exactly that, in a way I find moving. His name is Alberto Caballero, and he was not a professional astronomer at all. He was an amateur, a maker of online videos about exoplanets, a person doing serious science for the love of it from outside the institutions. He understood that the big ear's pointing was imprecise, that the signal could only be traced to a broad region of sky rather than a single star. So he did something patient and clever. He pulled the enormous catalogue of stars mapped by the European Gaia spacecraft, which has charted the positions and properties of well over 1 billion stars, a number so large it is almost meaningless until you realize that even counting one star every second, it would take you more than 50 years to count them all. From that vast catalogue, Caballero filtered down to the patch of sky the signal came from and asked a narrow question. Were there any stars in there, like our sun? The search returned almost nothing, which is itself the point. Out of that whole region, he found a single strong candidate. One star, sitting in Sagittarius about 1,800 light-years away, logged under nothing more than a long and forgettable catalogue number. And here is what stopped me when I read it. That star is, by every measure he could check, a near-perfect twin of our own sun. Its temperature is within a few degrees of the sun's. Its radius is essentially identical, within a fraction of a percent. Its brightness is, almost exactly, our sun's brightness. If you swapped it for our star, you might not notice. Out of all the directions the signal could have come from, the one sun-like candidate in the region is a mirror of the very star our own existence depends on. Let that distance settle into something you can feel. 1,800 light-years means the light we see from that star tonight left it 1,800 years ago. If a signal had truly been sent from there, aimed at us, it would have departed around the time the Roman Empire stood near its height, when Marcus Aurelius ruled and no one on Earth had any concept of a radio wave or another world. It would have crossed the dark for 18 centuries, outlasting the empire that was young when it left, arriving at last at a metal wall in an Ohio field in the summer of 1977, to be written down as 6 characters on a page and not noticed for several days. Whatever we hear from the stars, we are always hearing the deep past. We are always reading letters from senders who, by the time the words reach us, may have changed beyond recognition. or vanished entirely. So of course we did the thing we always do. We pointed our best instruments at that twin of the sun, and we listened. In 2022, the most ambitious modern search for alien signals, a program called Breakthrough Listen, aimed its equipment directly at that star, the first time anyone had ever made a focused search of it for the source of the WOW signal. It was a thorough look, far more sensitive than anything the big ear could have managed. They swept the star for the kind of narrow, deliberate signal a civilization might send, and it never came back. There was nothing. The twin of our sun sat there in the data, silent, ordinary, giving up no secret. The candidate that had felt so poetic, so almost too good to be true, returned the same answer every other piece of this search has returned for half a century. Quiet. I want to be careful here, because that silence does not prove the star is empty, any more than knocking once on a door and hearing nothing proves the house is abandoned. The signal, if it ever was a signal, came and went in a single burst decades ago. There is no reason a one-time event should still be repeating now for us to catch. And if the magnetar explanation is right, the star was never the source at all, and pointing at it was always going to find nothing. The silence of that star tells us very little, but it does tell us something about ourselves. It tells us how this search always seems to go. We find one promising thread, one almost answer, one point of light that makes the heart beat faster. And when we lean in close and truly listen, the universe declines to repeat itself. And I want to be clear that the WOW signal is not the only time the search has made our hearts leap. It is just the only time the leap never came down. The others are worth knowing, because the pattern they make is the most revealing thing about all of them. Skip forward to 2016. A Russian radio telescope picked up a strong burst of radio energy from the direction of a sun-like star about 95 light-years away in the constellation Hercules, a star already known to have at least one planet. Word leaked out, the headlines lit up, and for a few days the internet was certain we had finally heard from someone. Then the careful work was done, and the signal turned out to be terrestrial, almost certainly a stray transmission from a military satellite passing overhead. The excitement collapsed within the week. Then came the closest call of the modern era, and the one that felt, for a moment, like wow, happening all over again. In 2015, a $100 million listening program called Breakthrough Listen had been launched, with the backing of Stephen Hawking among others, the most ambitious search for alien signals ever mounted. In April of 2019, its astronomers used the Great Parkes Telescope in Australia to stare at Proxima Centauri, the very nearest star to our Sun, a mere 4 light-years away, which is known to host a planet in the zone where liquid water could exist. The data sat unexamined for over a year. And then, in late 2020, a summer intern named Shane Smith, combing back through it, found something. A narrow, needle-sharp signal, sitting at 982 megahertz, coming from the direction of the closest possible star, drifting in frequency the way a signal from a moving planet should, and present when the telescope pointed at Proxima and absent when it pointed away. They named it Breakthrough Listen Candidate 1. It was, by some distance, the most compelling thing the search had turned up since 1977. It passed filter after filter that should have caught ordinary interference. For a few months, a small number of people on Earth carried around the genuine possibility that humanity's nearest stellar neighbor was calling. And then a young researcher named Sophia Sheikh led nearly a year of painstaking analysis, and the candidate came apart in her hands. The signal was not from Proxima. It was a peculiar form of human-made interference, an electronic ghost produced by our own technology. The kind of thing that drifts and sharpens in just the way a real signal would. They went back and found dozens of lookalikes at related frequencies, all of them clearly junk from Earth. It was us, all along. The team called it, with a kind of rueful honesty, a dry run. Valuable practice for the day the real thing comes. And here is the pattern and the place it leaves the wow signal, which I find quietly remarkable. Every one of these modern candidates had advantages the wow signal never did. Better telescopes, the ability to point at the source and then point away to check, the ability to go back to the exact spot and re-observe, mountains of computing power and decades of hard-won technique for sniffing out human interference. And precisely because the modern candidates could be scrutinized that thoroughly, every one of them was eventually explained and set aside. They died because we could examine them. The wow signal is the one that got away. It was caught by a crude instrument that could not follow up properly in an era before any of those tools existed, by a telescope that physically could not turn to chase it, recorded on paper that no one read for days. And that very crudeness, that very poverty of follow-up, is exactly why it has never been killed. We could not point away to check it. We could not re-observe it in time. We could not run it through the filters that unmasked that Proxima candidate. There was nothing to run but 6 characters on a page. So it sits there still, unexplained and unkillable, while every better studied candidate that came after it has crumbled. There is something almost unbearable in that. Our single best piece of evidence for company in the universe endures precisely because it arrived in our least capable moment, and we have never been able to get a second look. And listening was never the only thing we did. Once, we spoke. 3 years before the big ear caught those 6 characters, on the 16th of November, 1974, a crowd gathered in the hills of Puerto Rico to celebrate the upgrade of the Arecibo telescope, then the largest single dish on Earth, a 1,000-foot bowl slung in a natural sinkhole. After the speeches, they used it to do something humanity had never deliberately done before. They shouted. Frank Drake, the same man who had run Project Ozma 14 years earlier, had composed a message with help from Carl Sagan and others, and they broadcast it into space in a burst of 2 tones that lasted under 3 minutes. Encoded in it were a few simple things. The numbers 1 to 10, the chemical building blocks of our DNA, a stick figure of a human being, a little map of our solar system, with the 3rd rock marked as home. They aimed it at a dense knot of several 100,000 stars called Messier 13, a globular cluster about 25,000 light-years away. And here is the part that puts the whole human enterprise in perspective. That message will not arrive for 25,000 years. By the time it reaches those stars, more time will have passed than separates us from the people who painted the caves at Lascaux. If anyone is there, and if anyone answers, the reply will not reach an Earth that Drake or Sagan or you or I will ever see. It was never really a phone call. It was a message in a bottle thrown into an ocean so vast that the throwing was the entire point. We did it, as one of the organizers admitted, mostly to prove that we could. Sit with the symmetry of those 2 events, 3 years apart. In 1974, we sent a single deliberate whisper out into the dark, one time, never to be repeated, that will not arrive for hundreds of human lifetimes. And in 1977, we caught a single whisper coming in, one time, never repeated, that we have never been able to explain. We shouted once, and we were answered once, if it was an answer at all. and neither the shout nor the reply will likely ever be resolved inside the span of a civilization. That is the strange shape of trying to talk across the galaxy. The distances are so enormous that a conversation is almost a category error. There is only ever the one whisper, sent or received, and then the long silence on either side of it. And there is one more thread worth pulling, because it is almost too neat. The telescope we used to shout in 1974, Arecibo, is the same telescope whose archived data, half a century later, would be used to propose that the whisper we caught in 1977 was a dead star and a cloud of gas. The same great dish at both ends of the story. And the year that signal arrived holds one more quiet coincidence that I cannot stop turning over. 1977. The same summer the Big Ear caught those 6 characters, NASA launched the 2 Voyager spacecraft, each carrying a golden phonograph record meant to outlast our civilization. A message in a bottle for whoever might find it in the deep future. And to tell that finder how to read the record, how to know our units of time and distance, the engineers engraved on its cover a small diagram of the hydrogen atom performing its spin flip. The very transition that produces the 21-centimeter line. They used the hydrogen line as the universal ruler, the one measurement any species anywhere would share, the cosmic standard you can build a whole language on. Stay with that for a moment. In a single year, 1977, we caught a mysterious whisper on the hydrogen frequency from the direction of the galactic center, and we flung 2 records into the dark engraved with that same frequency as our cosmic signature. We were speaking the hydrogen line and listening on the hydrogen line at the same time, sending and receiving on the one channel the universe hands out for free. Whatever those Voyager records eventually meet, and whatever that signal in Sagittarius truly was, they share a frequency. The note Van der Hulst imagined in occupied Holland turns out to be the closest thing we have to a common tongue with the cosmos, and we were both whispering it and straining to hear it in the very same year. This is the part of the story that moves from physics into something closer to the human condition. Think about what the search for that signal actually requires of a person. You point a telescope at a fixed strip of sky. You wait days for the Earth to carry it past your gaze. You read columns of numbers that are almost always nothing. You do this for years. The Big Ear's search ran for over 2 decades, the longest listening campaign of its kind ever undertaken. And in all that time, it produced exactly 1 page that made a grown scientist write an exclamation in the margin. 1 page. Out of years. And even that 1 page would not repeat itself when asked. And the reason it is so hard is worth feeling in your body. Because it is a problem of scale that almost defeats the imagination. To catch a signal, you have to be pointed at the right tiny patch of sky, out of the entire celestial sphere. You have to be tuned to the right frequency, out of an enormous span of the radio dial. You have to be listening at the right moment, out of all the moments there are, for however long the signal happens to last. And you have to be sensitive enough to hear it at whatever distance it has crossed. Get any one of those wrong, point a degree off, tune a little high, listen on Tuesday when it came on Wednesday, and you hear nothing, and you never know you missed anything at all. Researchers call this the cosmic haystack, and the haystack is so many dimensions deep that even after 60 years of searching, we have examined a vanishingly small fraction of it. We have, in effect, dipped a single drinking glass into the ocean, looked at the water in the glass, and found no fish. To then conclude the ocean is empty would be a kind of madness. The wow signal is the one time the glass came up with something flickering in it, and we have never managed to dip it in the same spot again. There is a particular kind of faith in that work that I do not think gets enough respect. It is the faith of people who keep the receiver tuned to the cosmic door year after year, knowing the overwhelming likelihood is that they will hear nothing in their lifetimes, doing it anyway, because the alternative, not listening at all, guarantees the silence will never be broken. Cocconi and Morrison saw this clearly back in 1959 in that closing line of theirs. The probability of success is hard to estimate, but if we never search, the chance of success is zero. The wow signal is, in a sense, the entire emotional history of that search compressed into 72 seconds. The thrill of the catch, the decades of trying to hear it again, the slow, patient, unrewarded listening that follows. And underneath all of it, the silence that has never truly lifted. Because that is the larger fact this one signal sits inside. We have been listening in an organized and serious way for more than 60 years now. We have built bigger ears, sharper receivers, faster computers, search programs that can sift through more of the sky in a day than the big ear managed in a year. And the sky, so far, has stayed quiet, not hostile, not empty in any way we can prove, just quiet. A vast, patient, unbroken quiet, with one ambiguous whisper from the summer of 1977 sitting inside it, the closest thing to a voice we have ever caught, and even that one whisper never came back. What you make of that silence says a great deal about how you see our place in things. Maybe the silence means we are alone, the only ones who ever learned to build a radio and point it upward and wonder. Maybe it means we are early, among the first to arrive at this strange trick of listening, calling out into a galaxy where the others have not yet woken up. Maybe it means everyone is out there, but no one is calling. Each civilization listening, none of them speaking. The whole galaxy a room full of people holding their breath. Or maybe it means nothing about anyone else at all. And the one time we thought we heard a voice, it was only a dying star sputtering in the dark, and the silence was never broken because there was never anyone there to break it. I cannot tell you which of those is true. No one can, and anyone who claims certainty is selling you something. What I can tell you is that the wow signal refuses to resolve the question either way. That is its strange, lasting power. If it had repeated, we would know we were not alone. If it had clearly been a satellite, we could file it away and move on. Instead, it sits forever in the middle, neither confirmed nor dismissed, a question mark we caught in a net and have never been able to either release or pin down. And here is the thread that even the implications cannot tie off, the question that hangs underneath all the others. Suppose the magnetar idea is confirmed someday. Suppose we find the dead star and the cloud and prove beyond doubt that those 72 seconds were a natural flare and nothing more. We will have explained the signal. We will not have answered the question the signal stood in for, because the silence would still be there. The sky would still be quiet. We would have lost our single best candidate for contact and gained nothing in its place to suggest we have company. Solving the wow signal does not tell us whether we are alone. It only takes away the one piece of evidence that briefly, beautifully, suggested we might not be. That is a strange kind of progress. To work for 50 years to understand a mystery, and to find that understanding it makes the universe feel emptier, not fuller. And it leaves one last door standing open, the one almost nobody walks through, the one that turns this entire story on its head. Here is the door. Most retellings of this story stop at the mystery or at the magnetar and never push through to what the 2024 work actually implies. And what it implies is larger and stranger than one signal from one night. Go back to why we chose the hydrogen line in the first place. Cacconi and Morrison and Drake and Oliver all landed on 1420 megahertz for the same reason. It is the frequency of hydrogen, the most common substance in existence, the one note the whole universe already sings. They reason that any civilization would know it, because every civilization that builds a radio telescope hears that hum the moment it looks up. The hydrogen line was supposed to be the perfect channel, precisely because it is universal. It belongs to no one. It is written into the structure of matter itself. That universality was the entire selling point. That was why it felt safe, obvious, incorruptible, the one frequency you could trust. And now look at what Mendez and his colleagues are suggesting. They are suggesting that a cloud of hydrogen, the very substance that defines the frequency, can be lit up by a passing burst of energy and made to flare briefly and brilliantly on its own line, which means the exact property that made the hydrogen line the perfect listening channel. The fact that it is the frequency of hydrogen is the very same property that lets nature counterfeit a signal there. The universe can forge a false hello on the one channel we trusted most, using nothing more exotic than the most ordinary gas in the cosmos and an occasional violent star. Think about the cruelty of that. If you are someone who has spent a career listening, we picked the frequency we thought no natural process could fake, the clean, quiet doorway where only a deliberate caller would knock. We even passed international laws to keep our own transmitters off it, to keep the doorway pristine. And it turns out the doorway was never pristine at all. The cosmos itself broadcast there, not just as the steady background hum we always knew about, but occasionally, rarely, as a sharp-tuned flare that wears the exact disguise of the signal we were hoping to catch. We can silence every transmitter on Earth. We cannot silence the sky. This is the part that I think reframes the search itself, and it is why Mendez's paper matters far beyond solving one old puzzle. What the team has really proposed is a brand new kind of false alarm, a natural phenomenon that nobody had accounted for, that produces narrow, strong, non-repeating signals at the hydrogen line, the precise profile that sets off every alarm bell in the search for intelligence. For nearly 50 years, the standard story has been that a narrow signal on the hydrogen line that does not repeat is exactly what a real alien beacon might look like. Mendez is suggesting that it is also exactly what a magnetar flaring behind a hydrogen cloud might look like. Those two explanations, the most exciting one imaginable and a purely mechanical one, can produce the same fingerprint. And if that is true, then every future search has to reckon with the fact that the dream signal and the natural imposter can be indistinguishable in a single observation. And here is the thing that turns this from a clever idea into something we can no longer wave away. We used to think the radio sky was mostly calm, broken only by the steady glows of stars and gas. We were wrong, and we found out how wrong only recently. Since 2007, astronomers have been picking up something they call fast radio bursts, flashes of radio energy that last 1,000th of a second, blindingly bright, arriving from all over the sky, most of them from far outside our own galaxy. For years, no one had any idea what they were. They were the hottest mystery in radio astronomy, and the leading suspects were exotic. And then, in April of 2020, we caught one in the act, close to home, and it settled the argument in the most relevant way possible for our story. A magnetar in our own galaxy went into a violent flaring fit. Space telescopes saw it spitting X-rays and gamma rays, and on the 28th of April, two independent radio projects, one in Canada and one in the western United States, caught a brilliant burst of radio waves coming from that exact magnetar at the very same instant as a burst of X-rays. It was the first fast radio burst ever traced to a source inside the Milky Way, and the first ever pinned to a specific object. The burst was something like 1,000 times brighter than any radio pulse a galactic magnetar had ever been seen to make. And one of the two detections came in right around 1400 megahertz, in the same neighborhood of the dial where the WOW signal lived. Read what that means against everything we have said. We no longer have to imagine that a magnetar might produce a brief, intense, narrow burst of radio energy near the hydrogen band. We have watched one do it in our own galaxy in real time. The idea at the heart of the magnetar explanation for the WOW signal stopped being speculation and became something with a living, observed example behind it. The radio sky is not the calm pond we once pictured. It crackles, it flashes, it is full of brief, bright, one-time events from dead and dying stars. Events we are only now, in the last 20 years, learning to catch at all. The waterhole, the quiet meeting place, turns out to sit in a sky that pops and sparks with natural fire. There is a quieter line buried in the team's work that captures the whole strangeness of it. They suggest that the WOW signal, the most famous candidate for an alien message in history, might instead be something nobody had ever recorded before. The first observed example of a hydrogen cloud flaring like a natural maser at the 21-centimeter line. Read that again and feel the size of it. For half a century, we have wondered whether those 72 seconds were the first time another mind reached us. The new possibility is that they were a first of an entirely different kind. Not the first message from someone else, but the first recording of a natural event we did not know could happen. Either way, the WOW signal is a first. The only question is what category of first it belongs to. A landmark in the search for company, or a landmark in the physics of dead stars and cold gas. And here is a detail that almost never makes it into the popular tellings, one that compounds the mystery rather than easing it. We do not actually know exactly where in the sky the signal came from. Remember the two ears, the two feed horns. The trouble is that because of how the data was recorded, no one can be entirely certain which of the two horns actually caught the signal. And the two horns were looking at slightly different patches of sky. So the WOW signal does not have one location. It has two possible locations, two narrow strips of Sagittarius, and we have never been able to say for sure which one is the true source. Every search of that region, including the search for the magnetar and the search around that sun-like twin star, has had to contend with the fact that we are not even certain where to point. 50 years on, we cannot fully agree on the address the most famous signal in history came from. That uncertainty is part of why this will be so hard to ever close. To confirm the magnetar idea, someone would need to find the specific dead star or the specific cloud behind one of two possible patches of sky. For an event that lasted 72 seconds, nearly 5 decades ago, and left only the faintest trail. It may simply be beyond our reach. The signal may have erased its own return address the moment it faded. There is one more thing that the Arecibo work throws into sharp relief, and it is the detail I find quietly the most haunting of all. Consider how much radio astronomy has grown since 1977. The big ear was a fine instrument for its day, but it has been outclassed many times over. We have built arrays of dozens of dishes working in concert, single telescopes with collecting areas the old observatory could never dream of, search programs that listen to millions of channels at once instead of 50. We have poured decades and fortunes into listening to the sky at the hydrogen line. And in all of that listening, with all of that vastly superior equipment, we never once caught anything like the wow signal again. Not a single repeat of that strength and clarity. It took until 2024, sifting through the archives of one of the largest telescopes ever built, just to find faint cousins 60 to 100 times weaker, barely whispering where the original had shouted. Consider what that means. Whatever produced those 72 seconds was not just unusual. It was, by the standard of everything we have detected before or since, genuinely extraordinary. If it was a magnetar flaring behind a cloud, it was a freak alignment of rare things, a once-in-many lifetimes accident of geometry that has not recurred in 5 decades of far better watching. And if it was not a magnetar, if it really was something reaching out on purpose, then we caught the one and only transmission it ever sent in our direction. In the few years we happened to have a telescope pointed at that exact strip of sky, and we have been waiting for a second word ever since. Either way, we caught lightning, the kind that does not strike the same place twice in any span of time that means anything to a human life. Which brings the whole story back around to the thing it has been circling from the start. The title we give this signal, the thing that has made it legend, is that it never came back. For 50 years, that phrase has carried a kind of romantic dread, the sense of a hand reaching out of the dark once and then withdrawing, a voice that called our name and went silent before we could answer. But the new science quietly turns that phrase inside out. If the magnetar idea holds, the signal never came back, not because something lost interest in us, not because a civilization fell silent or a beacon switched off. It never came back because it was never the kind of thing that comes back. A dead star convulses once. A cloud flares once. The accident does not repeat. The absence we have spent 50 years mourning may not be an absence at all. It may simply be the natural shape of the event, complete in itself, with no second act ever intended. And there is a second overlooked truth tucked inside the first, one that I think is almost more unsettling than the question of what the signal was. It is the question of what we would have done if it had come back. Because here is something most people never think about. We have spent 70 years building the machines to detect a signal, and far less effort deciding what happens the morning after we find one. The wow signal, in a strange way, was a dress rehearsal, and we flunked it. We caught the best candidate in history, and our response was confusion, delay, and decades of failing to confirm it. No alarm went off. No protocol kicked in. A volunteer found it on paper days later and wrote an exclamation in the margin. And that was the entirety of our species' reaction to possibly the most important 72 seconds in its history. We have tried since then to be more ready. In 1989, the international body that thinks about these things drew up a formal document with a suitably grand title, the Declaration of Principles Concerning Activities following the Detection of Extraterrestrial Intelligence. It is, in effect, a rulebook for first contact, and it was shaped, in part, by exactly the kind of false alarms we have been talking about, including an early scare in the Soviet Union, born of Cold War nerves, when a signal was briefly mistaken for a sign of someone out there. The Declaration lays out sensible steps. Before you tell the world, Get independent confirmation from other observatories so you do not embarrass everyone with a satellite or a glitch. When you are sure, announce it openly to everyone rather than hoarding it. Share the data. And then comes the line that stops you cold. No reply should be sent to any signal until there has been international consultation. In other words, no single person, no single country gets to decide on behalf of all 8 billion of us to answer the phone. There is even a tool called the Rio scale, designed to rate how seriously a claim detection should be taken, running from 0 to 10, folding in how credible the signal is and how big the consequences would be if it were real. By that measure, the wow signal sits in an uncomfortable middle, tantalizing enough never to dismiss, unconfirmed enough never to celebrate, a signal that scores just high enough to keep you awake, and just low enough that you can never act on it. But the rulebook hides a much deeper disagreement, and it is one we have never resolved. Should we answer at all? Should we be calling out in the first place? Remember that in 1974, a handful of people at Arecibo decided, more or less on their own, to broadcast humanity's existence toward a cluster of several 100,000 stars. They did it as a demonstration, almost a flourish. And not everyone thinks that was wise. There is a serious camp, which has included some of the most thoughtful minds of our age, that regards deliberately shouting our location into the dark as one of the more reckless things a young civilization could do. Stephen Hawking put it bluntly. He pointed out that on Earth, when a technologically advanced culture met a less advanced one, it rarely went well for the less advanced one, and suggested we might do better to listen quietly than to announce ourselves. In 2015, a group of scientists and thinkers signed a public statement urging exactly that caution, arguing that no message should be sent on behalf of the whole planet without a broad global conversation first. Others find that timid, even pointless. We have been leaking radio and television into space for the better part of a century already, they argue. That horse has bolted. The quiet is an illusion, and if anyone capable of harming us is close enough to listen, they already know we are here. Better, on this view, to call out deliberately and clearly than to cower. It is a genuine, unresolved argument, and underneath it sits the oldest unanswered question of the whole enterprise, the one Carl Sagan asked and no one has been able to answer. Who speaks for Earth? There is no agreed answer. There is no procedure that would actually hold if a real signal arrived tomorrow. We have the listening machines and the lofty declarations, and almost no real plan for the one thing that matters, which is what we, all of us, would actually do. And this is not a hypothetical quarrel. One man went ahead and answered for all of us. In 1999, and again in 2003, a Russian astronomer named Alexander Zaitsev used a powerful 70-meter radar dish at Evpatoria in Crimea to beam deliberate messages called the cosmic calls at a handful of nearby sun-like stars. The content was crowdsourced, partly funded by a private company, made up of images and sounds and text submitted by members of the public. Zaitsev believed deeply that humanity should announce itself, that hiding was both futile and a little cowardly, and he acted on that belief. He did not take a vote. He did not consult the world. He pointed a transmitter at the stars and, on behalf of every person alive, said hello. The transmissions were controversial from the first day. At one point, the Ukrainian space authorities, alarmed, briefly halted the broadcast. But by then, the photons were already on their way, and they are still traveling now, carrying our existence outward towards stars we will never visit, sent by one man who decided he had the right. Whatever you think of what he did, it lays the real problem bare. There is no lock on the door. There is no global hand on the transmitter. Any nation, any wealthy individual, any well-funded group with access to a big enough dish can decide tomorrow to shout our coordinates into the dark, and nothing in any treaty can truly stop them. And the WOW signal sits in the middle of all of it, mocking the whole apparatus a little. We built protocols for confirming a detection, and the one signal that came closest could never be confirmed. We built rules forbidding a unilateral reply, and there was nothing to reply to. No second word, no address we could even be sure of. We argued for decades about whether to answer the cosmos, while the closest thing to a question it ever asked us faded off a piece of paper before anyone was even in the room. Our grand machinery for first contact has never once been triggered for real. The WOW signal is the nearest it has ever come to being needed, and it's slipped through every part of it. And yet, even now, even saying all of that, I cannot quite close the door, and neither can the people who study this for a living. Because the magnetar has not been found, the cloud has not been pinned down. The two possible addresses still sit there, unresolved. And the oldest, simplest reading of those 6 characters, the reading a cautious man with a red pen would not quite rule out and would not quite endorse, is still standing where it has always stood, in the doorway, neither inside nor out. So the overlooked truth of the WOW signal is not that we solved it, and not that we failed to. It is that the closer we look, the more it dissolves into something even stranger than a message. It becomes a mirror, showing us the exact shape of our own hope and the exact shape of our own ignorance at the same time. On the one frequency we were sure we could trust. We went looking for a voice in the dark, and what we found in the end was a question we still do not know how to answer and may not even know how to ask. The Big Ear did not survive to see any of this resolved. In 1998, the land it stood on was sold to developers, and the Great Telescope, larger than 3 football fields, the longest listening ear humanity had ever built, was taken apart and hauled away to make room for houses and the expansion of the golf course next door. There was a fight to save it. The people who understood what had been done there, who knew that this unlovely sprawl of metal in an Ohio field had caught the most tantalizing signal in the history of the search, pleaded with the owners and wrote their letters and lost. John Krause, the man who had designed it and given his working life to it, lived to watch his great instrument come down. The metal walls were dismantled. The vast aluminum plane that had bounced the whispers of the galaxy toward 2 patient horns was torn up and carried off. The small control building, where the paper had piled in quiet stacks, where a man once sat with a red pen and circled 6 characters and wrote a single astonished word in the margin, was gone. And here is the detail I have not been able to shake since I first learned it. The exact spot where the telescope stood, the patch of Ohio ground that held the only instrument ever to catch a clear whisper at the waterhole, is now a small pond on that golf course, a water hazard, a still circle of water on a fairway, sitting precisely where the Great Ear used to lift its gaze to the sky. Think about the name one more time. Barney Oliver called the listening band the Waterhole, the cosmic watering hole, the place, he imagined, where the creatures of the galaxy might gather warily at the radio dial, the way animals gather at the water's edge, all of them drawn to the same essential thing. We built our ear at the waterhole, and we waited for the others to come and drink. And the ground we listen from is now, in the most literal an unintended way anyone could imagine, a watering hole of its own. A quiet pond on a golf course in Ohio, reflecting the same night sky the telescope spent its life reading. There is something almost unbearably gentle about that to me. We reached for the stars from that spot. We caught the one thing we ever caught, and then we let it become a place where the grass is mowed and the water sits still, and most of the people who walk past have no idea that the strangest sound humanity ever heard was first written down a few steps from where they stand. And think of the people who passed through this story, because they are the quiet heart of it. John Krause, who built a new kind of telescope out of cleverness and thrift and pointed it at the whole sky. Bob Dixon, who kept a threadbare search alive for decades on almost nothing, year after patient year. Jerry Amon, who was careful to the last, who would not let himself or anyone else overclaim, who carried those 6 characters with him for the rest of his life and never once pretended to know more than he did. Robert Gray, the amateur from Chicago who loved the mystery so much, he chased it across 4 observatories and 2 hemispheres and a quarter of a century and died without his answer. Not one of them got to know what the signal was. Every one of them gave years of their life to the simple, unglamorous act of paying attention to the cosmos on the chance that it might say something back. That is its own kind of quiet heroism, and it almost never gets named. But here is the thing the pond cannot touch. The telescope is gone. Everything it was pointed at is exactly where it was. That crowded strip of Sagittarius still rises over Ohio every night and drifts slowly westward as the Earth turns. The same patient drift the big ear once used to carry the sky across its gaze. The hydrogen line still hums across the whole heavens, the universe singing its single quiet note to itself, the way it has since long before there was anyone here to name it. The channel is still protected. The same old treaties still keep our own voices off it, still hold the cosmic doorway clear, just in case. And we are still listening, with ears far larger than the one we tore down, with arrays of dishes and oceans of data, and a patience that has outlasted the people who started it. We sweep that patch of Sagittarius and 1,000 others, night after night, year after year, one generation quietly handing the receivers to the next. The 6 characters survived too. 6, E, Q, U, J, 5. The printout was kept, preserved, photographed, studied for half a century. The telescope that heard it is a pond now, but the record of what it caught is safe. Those 6 characters are still the loudest, narrowest, most haunting thing we have ever found on the frequency we share with the entire galaxy. They have outlived the machine that caught them and the men who chased them. Whatever they were, a dead star flaring once in the dark, or a hand reaching once across 1,800 years, they remain the closest we have ever come to an answer. And still, it never came back. Maybe because it was a magnetar, flaring once behind a cloud of cold gas and falling dark forever. Maybe because there was never anyone there at all, and the silence was always only silence. Maybe because the thing that sent it has been gone for 18 centuries, and we caught the final word of a sentence that ended before Rome fell. We do not know. We may never know. But the not knowing is not the same as the silence. The not knowing is the reason we keep the channel open. So here is where I will leave you. Not with an answer, because there isn't one, but with the open door. Somewhere above you, right now, that same strip of sky is turning. The hydrogen line is humming over your roof, the way it hums over every roof on Earth. the way it hummed over that Ohio field on a warm August night, before anyone knew what the paper would say. The channel is open. It has always been open, and whether or not a voice ever comes across it again, the simple fact that we built a thing to listen, that we agreed to keep our own noise off the cosmic frequency on the chance that someone else might call, that we have stayed at the water's edge for more than 60 years and are standing there still, says something quiet and good about us that no silence can take away. We are the species that kept the line open. You can let yourself drift now. The listening does not need you awake for it. Out in Ohio, the pond lies still beneath the stars, exactly where the Great Ear used to stand, and the sky it watched goes on turning without it. Sagittarius wheels slowly overhead, the bright, crowded heart of the galaxy pouring its light down through 1420 megahertz, the same channel, the same hum, the same open door it has always been. Somewhere out there, a cloud of hydrogen still drifts in the cold. Somewhere, perhaps, a dead star waits to flare again. And down here, on one quiet world at the edge of one ordinary arm of the galaxy, the receivers are still on, still tuned to the waterhole, still listening for a voice that came once, for 72 seconds, and then never came back. The channel is open. The sky is turning, and someone, somewhere is still awake, watching the quiet for the next 6 characters to fall, just in case.